Permutations and combinations. A permutation is an arrangement of objects in which order is important. A combination is an arrangement of objects in which order is not important. Let's go ahead and take a look at some permutations. In our first example, it says there are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? Now let's think about this. Let's think about why the order is actually important and why this is a permutation rather than a combination. If you think about it, if we have 3 winners, then all 3 of these winners are probably going to want that gold medal because they're all going to want the first prize position. But not everyone is going to get that first place position. There's going to be a second place position that gets a silver medal and a third place position that gets a bronze medal. So the order is important here because if I finish first, I don't want a bronze medal, I want the gold medal. So here the order does matter. And the number of permutations of indistinct objects taken R at a time can be given by a particular formula. And our formula is n factorial over n minus r factorial. So we can use that formula to be able to actually solve this problem. So what we're going to do is think about, okay, what is n and what is r? So it says the number of permutations of n distinct objects taken r at a time. So in this case, n is going to be 10 because there's 10 finalists. And then we have to figure out what r is. Well, in this case, r is going to be 3 because that's how many medals there are. And now all we're going to do is plug this into our formula. So we're going to have 10p probability 3 equals 10 factorial over 10 minus 3 factorial. We can go ahead and simplify this to 10 factorial over 7 factorial. And if we go ahead and we write this out and we see how we can reduce this, we know that factorial just means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 7 factorial is going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. And now we can reduce. 7 through 1 are going to cancel on both ends. So we're going to have 10 times 9 times 8, which is going to give us 720 for our final answer. So the gold, silver, and bronze medals can be awarded in 720 different ways. We also have permutations that have repetition, and we're going to look at an example of that. But first, we can go ahead and write down our formula. The number of permutations of n objects of which p are alike and q are alike is n factorial over p factorial times q factorial. Our example that we're going to be using is how many different ways can the letters of the word Mississippi be arranged. So it's really, really important here because a lot of these letters are repeated, and that's really important. So first, we know that n is going to be 11 because there are a total of 11 different letters. So n factorial is going to turn into 11 factorial. And then we have p factorial times q factorial. So we want to find out what's repeating here. Well, we know that the letter I occurs 4 times, so we have to include 4 for our I. We know that S occurs 4 times, so we have to include 4 factorial for the S. And then we know that P occurs 2 times, so we have to include 2 factorial for the P. So you could go through and do all of this, but you can also use a calculator to simplify this. And if you put this into your calculator and simplify it, you're going to get 34,650. So that means that there are 34,650 ways to arrange these letters. So with combinations, remember that the order is not important, and we're going to have a formula for this one as well. With the number of combinations of indistinct objects taken R at a time, we're going to have our formula of n factorial over n minus r factorial times r factorial. So our example says that a group of 7 students working on a project needs to choose 2 students to present the group's report. How many ways can they choose the 2 students? So let's talk about why this is a combination and not a permutation. So this is going to be a combination because no matter what, 2 students are going to get chosen. It doesn't really matter if one student gets chosen first and the second student gets chosen second, because these students are going to have to do the same job. Nothing's different, they're just both reporting something. So what we want to do here, we want to figure out what n is and we want to figure out what r is. And we know that for n, they're choosing from 7 students, so n is going to be 7. And then we ask ourselves, okay, what's r? Well, they're choosing 2. So we're going to have our formula set up where we have 7 factorial over 7 minus 2 factorial times 2 factorial. And now we can go ahead and subtract. So we have 7 factorial over 5 factorial times 2 factorial. And then if we write all of this out, we're going to be able to simplify. So we have 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 5 times 4 times 3 times 2 times 1 times 2 times 1. Now we can get rid of the same things. We have 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. So we're going to end up with 7 times 6 over 2 times 1 is 2. So we're going to end up with 21 is our final answer. So there are 21 possible ways to choose the 2 students. And I wanted to actually go ahead and throw this common scenario in here that you'll see when you're working with probability a lot, just in case you're unfamiliar with the deck of cards. So if you're unfamiliar with the deck of cards, we have an ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, and 2. Okay, so we have 4 different suits, and we represent our suits. We have a spade, we have a club, and these are black cards, okay? And then we also have a heart, and we have diamonds, which are red. So each of these suits has an ace, a king, a queen, a jack, and so on and so forth. So there are 4 aces, 4 kings, 4 queens, 4 jacks, etc. And that's going to come in handy because you will be seeing some probability questions where you're going to have to use that information. A probability distribution for a particular random variable is a function that maps the sample space to its probabilities of the outcomes in the sample space. So we'll be dealing with that when we're looking at example 4. And we have a spinner that we're going to be using, and we can see the probability distribution of the spinner landing on each color. So we're going to answer a couple of questions based off of that. So first, question A says, what is the probability of it landing on purple, and why? Well, if we look at our purple area here, our probability of it landing there is going to be 1/4. And that's going to be the reasoning, which I'm not going to write down, we're just going to discuss. The reason that it's going to be 1/4 is because out of the entire board, 1/4 of the board is purple. So that's why our probability here is going to be 1/4. Letter B says, what is the probability of it landing on red or green? So we have to figure out the probability of both of these. So first, if we're looking at the probability of red, we know that the probability is 1/12 based off of what the graph says. For it landing on green, we know that our probability is going to be 1/6 because that's what green is marked on our spinner. So in order to get the probability of it landing on red or green, we're going to go ahead and add these two together. So we have 1/12 plus 1/6. And remember, when we're adding these, you can plug this into your calculator if you want, but if you're doing it longhand, we'll multiply both of these just by 2 so that we can change that bottom. So we're going to have 1/12 plus 2 over 12. And now we can add them. So we're going to end up with 3/12, which reduces to 1/4. So there's a 1/4 probability that the spinner is going to land on 1/12 or 1/6.